Today we're going to look at a high school physics question. This physics question is meant for either AP exams or physics contests. This is actually quite an easy question. It's a warm-up question. One thing important to note here is this is actually got a multiple choice question. We're looking at a multiple choice question. We want to look at ways we could perhaps eliminate some of these answers quickly. And we'll show you how to do an estimate. An estimate will eliminate some of these answers and also can be used to check to make sure that our calculated answer is not one of the eliminated answers. If it is, it tells us our calculated answer is wrong. So let's begin. Romeo is landing back on Earth to claim his bride, Juliet. His spaceship is descending vertically at 50 meters per second. He's 500 meters up. He throws a bouquet of love-in flowers horizontally from his point of view, out the spaceship to land near Juliet, who's waiting in a dockport 40 meters from his landing spot. We're going to assume that this is horizontally from his landing spot, which the only thing makes sense. How fast must Romeo throw his flowers in meters per second so they land near Juliet's feet? The love-in flowers are very slippery and do not experience air resistance. Okay, that's actually important as well. They can also absorb quite a shock on landing and still look fresh. Well, okay, Juliet cares, but it doesn't affect our question. One thing we do need to consider is this air resistance here. What does it mean? So if you had a hand or an object, going through the air, and air is like, these air particles, air molecules are here. This hand needs to push its way through so it's going to kind of compress these air molecules on the face side, and it's going to leave it kind of like an open space or a vacuum on the trailing side. And this causing a compression of the air molecules on the front side and the vacuum on the back side is going to create an air resistance. And this air resistance is basically a force times an acceleration. What does that actually mean? Well, we do have two things going on here. We have the flowers being thrown horizontally, and they're also traveling vertically. What we know is traveling horizontally, if there's no air resistance and no other force, so whatever beginning velocity we start with, that's going to be the velocity we're going to end with. What do we know about the vertical velocity? What we do have is the planet Earth. So the planet Earth does have a gravitational acceleration, which is 9.8 meters per second squared. And if we don't have any air resistance, it's going to keep acceleration without limit. If we did have an air resistance, there would be a time when the force due to gravity and the force due to air resistance, a resisting force, would equal, and we would have like a terminal velocity. But we don't have this situation because there is no air resistance, there is no terminal velocity, so it's a simpler. So what we'd have is we have initial velocity, and because of gravity accelerating us downwards, we're going to have a final velocity. And the final velocity is going to be greater than the initial velocity. So let's draw this diagram. We have Romeo's spaceship, and he's above a spaceport by about 500 meters. Okay. We have Juliet standing over here from the spaceport. She's about 40 meters away. Now, we have Romeo in his spaceship as he's throwing the flowers descending at 50 meters per second. Let's just draw seconds that way. We have the question, what we're trying to figure out. He's throwing these flowers. Let's draw a different color. He's throwing these flowers horizontally from his point of view. And we want to know how fast he has to throw these flowers in meters per second so they land at Juliet's feet. Now, the first thing we do know is when he throws these flowers out horizontally, they actually have at the same time have a vertical component, because it's from his point of view. He's moving down vertically. So as he's moving down vertically, they're also going horizontal. So they're actually going in, from a third person watching this, they would see it actually going down at an angle, because it may appear from as he's going down these different points, it's going further out, and from his point of view it's horizontal, but from a third person watching it, they can see an angle. As he throws it out, it's going to accelerate vertically by gravity, and it's going to make a curved path to land at Juliet's feet. Now this is, well, let's say land at Juliet's feet, all the way down here. So when it hits the ground, that's going to be the end of its flight. So we're just going to call that time t, the time it hits the ground. And it's also the same time in these flights traveling horizontally. It's exactly the same time traveling horizontally as well. So they're going to travel horizontally until they hit the ground. Now another thing we do know is the horizontal velocity is going to remain constant as such. At the same time, the vertical velocity is going to be increasing because of gravity acceleration. The vertical velocity, initial velocity, that's this initial velocity, and the final velocity, let's say right that. And so back to our question, what is the velocity in meters per second? And velocity equals displacement over time. Another way of thinking about this, velocity displacement over time, if you have x of horizontal displacement times velocity, the faster you're going in a given time, the greater distance you're going to travel. So if you go very fast for a set time, you're going to go further. So if you're driving 60 kilometers an hour for 1 hour, you're going to drive 60 kilometers. If you're driving 120 kilometers in 1 hour, you're going to drive 120. So as is proportional. And similarly, if you're driving 60 kilometers for half an hour, you're going to drive 30 kilometers. And 60 kilometers for 1 hour, you drive 60 kilometers. So this is your basic equation. So what do we have? We have, this is the x is 40, and we have the vertical y, here was 500. So what we have here is 40 meters over t time. Now the question is, we don't know what this time is, but we can make a guess. Let's just make a simple guess. We know that the from this, using this equation up here, we know that vertical displacement equals the vertical velocity times the vertical time, which is basically the same. The vertical time and the horizontal are the same. So what is the vertical velocity? Well, the vertical velocity is, because we have an acceleration which is uniform, it's not a varying acceleration, is simply the average of the initial velocity plus the final velocity times time. And we don't know the final velocity, but we do know it's greater than initial velocity, but we don't know by how much. So we know the time is going to be, let's say we just said it, let's say the estimated time. The estimated time, so let's just do v1 times time. This estimated time here, because this velocity is clearly larger, the estimated time here is going to be greater than the real time. Because if you travel a distance faster, then it's going to take less time to travel. So this is the slow travel, therefore it's going to take longer to travel than the fast travel. So what is the, and this here is going to give you, so let's say, what is this time going to be equal? Well, we do know that time, in this case, is the displacement over velocity v1. And then we're going to write the units out to make sure we got it right. That's 500 meters over 50 meters per second. The meters cancel out and the second goes on the top, so we actually have seconds on top. So this is in time. And what we get as a result is 10 seconds. We know that's too much, so or too much time. So if we look at that, what is the velocity with this estimate? Well, if so we have 10, and we know that this time is going to be longer than it should be. That means there's going to be a slower velocity. So we know that the real v, oh, so let's give it a different color because it's horizontal. The real v is going to be greater than this estimated v. And the reason we give it a different color is I'm trying to make sure we kind of stay on track of this, because this here is actually the horizontal, and this one here is the vertical v. Well, different, same color, but these are vertical v and this is the horizontal v. So I'm trying to draw the horizontal v in orange so we can keep track of that. So we do know that this here is 4 meters per second, and we know when I see here the horizontal real v is going to be greater than that. So we know that anything less than, or anything not greater than 4 meters per second is not possible. So that 4 meters per second is going to be greater than that, so that's not possible. And clearly the other ones are also not possible. This is as an exam question, we want to do things as quickly as possible. And this is a really good start because we already got down to 2 possibilities. Now, what's the next step? As an exam question, we look at the number of significant digits. This has got 3 significant digits. Okay. And another thing to kind of like pay attention to is like, what's the difference between this? Well, this is a difference greater than 1. So if I had a calculation to 1 significant digit, this would be enough to get me the right answer. And this is kind of important because it's going to save you a lot of time going forward. So let's start here now using this equation we have for displacement. What else do we know? We know that acceleration equals the change in velocity over time. And what is the change in velocity? In this case, the change in velocity is v final minus v initial over time. And we can rewrite this as, let's just do that again over here. This is AT equals velocity final minus velocity initial. And this makes sense. The amount, well, let's just write one more step here. Velocity final equals acceleration times time plus velocity initial. This makes sense because the velocity initial without acceleration will be velocity final. Well, because acceleration, the longer the acceleration applies, the higher the final velocity. So this definitely makes sense. So we can plug this back in to the equation above. We have y equals 1/2 velocity initial, and they have velocity final. Well, velocity final is plus AT plus V1 all times t, because this is a t here, all times t. Now we write that through. Now we just kind of jumping down from our previous work and below this, what we have is y equals, now we have 2 v1s here, so that's going to be 2 v1 over 2, and we have the times t plus a, and we've got t times t squared. This cancels out, so what we get, if I just, oh, and also we got a half here, don't forget that. We have 1/2 at squared plus v initial times t. Now, we do already know that this is Earth's gravity. Earth's gravitational constant is 9.8 approximately. In that case, this is going to be our A. We're going to use A is going to be G. So putting this in, what we get, just writing this through, we get 500 meters equals 1/2 9.8 meters per second squared. Now it's a good idea to write the units in At the same time, we're doing the substitution because this verifies that the equation is correct. Now we've got times t seconds squared plus 50 meters per second, that's the initial velocity, times t seconds. Now let's just make sure this equation works. We have seconds squared times second squared here, so these cross out, that leaves us in meters. We have meters per second times time in seconds, so that leaves us also in meters. So this equation works out into meters, and let's just work out what it's going to be. So let's say we have 0 equals, we have 9 divided by 2, which is 4.9 t squared plus 50 t, and this becomes across the other side, minus 500. Okay, so since we only need one significant distance, because we just kind of calculated that already, we don't really need to do in full resolution or full precision. What we can do is, instead of saying this is 5, we can say, instead of saying 4.9, we can say it's approximately 5. So we can make another approximation. We can say 0 equals t squared, and assuming this was 5 or close enough, this would be plus 10t minus 100. And it's really kind of important when you're doing multiple choice questions like this here, when you notice these important details, to do things quickly. And this makes it much quicker. Now, at this point, we have two choices. We know the form of the result is going to be t squared, like t times t, and then a minus and a plus. We don't know what those are, and the way we typically solve this is using the quadratic equation, which is let's do a different color again. The quadratic equation is a t squared plus b t plus c equals 0. And then we have t equals minus b plus or minus the square root of, just a little mistake there, the square root of b squared minus 4ac all over 2a. Now, this is not as complicated as it looks when you use these numbers, because we're using these numbers here. This is actually quite straightforward. We have t into the first significant digit is t equals, let's just write out what a, b, and c is. A is 1, b is 10, and c equals minus 100. Now, I really kind of recommend when you're doing this, you kind of spend an extra second to write it out, because it just makes it easier, less likely to make a mistake. So 10, that's a problem with writing here actually. That becomes minus 10, and we get plus or minus the square root of 10, which is 100, and 4, and we have a is equal to 1 and c is equal to minus 100, so minus 4 times minus 100 is plus 400, and we have 2 and a and 1 again, so that's equals to this. Now, if we work through this portion over here, I'm just going to do a different color. This is actually equal to square root of 500. Now, square root of 500 is equal to the square root of 5 times the square root of 100, but the square root of 100 is 10. Okay, so we could say this as minus 10 divided by 2 plus or minus 10 square root 5 divided by 2. That's 5, and that's 5. So we work this out. T equals, should we just put the 5 outside here? 5 minus 1 plus or minus square root 5. Now, if we look at this for a second, if we use the minus 1 right here, the minus sign, that would give a minus time. So a minus 1 subtract a minus 5 is going to give us minus number. So because it's going to give us a minus number, we know that minus time is not possible. So we know the only answer is going to be the top one. So if we just enter it in the calculator for a second, what would we get? We would get 5 square root minus 1 times 5 equals. So that gives us t, in this case, equal to 6.18. Then putting that into our equation over here, we have we're going to call this velocity horizontal, so just don't forget what it is. It's 40 divided by 6.18. And that should be good enough precision to decide whether the answer is D or E. Let's just do that. 40 divided by 6.18, and the answer is 6.47. And I'm quite confident that this is within, one, and it's very close to the other one. Now, one more check we can do. If we go back and look at these two here, we know that divided by 4.9 versus divided by 5. Divided by 5 is going to make the time, all these numbers, coefficients, slightly smaller. That means this time versus the, let's get the right color here. Versus the real time, the estimated time versus the real time. The estimated time is going to be ever so slightly, let's see which it's going to be. The estimated time here, because it's going to be slightly larger. Is that right? No, it doesn't appear to be slightly larger. The estimated time here, because of t, is going to be slightly smaller than the real time. And the reason for this is the real time is bigger, because if we divide by a smaller number, it would get bigger coefficients. For example, the actual numbers divided through, and this is what I'm going to show you, is how come the real time is slightly larger than the estimated time is. It's going to be t squared, and then 50 divided by 4.9, 50 divided by 4.9 is 10 point, so it's hard to write here. 10.2 t, and then minus, because we're shifting just one place, it'd be equal to 102. And you see the coefficients are larger. That means the real time is going to be ever so slightly larger than the official time, or the estimated time. If the real time is ever so slightly larger, that means the velocity is going to be ever so slightly smaller. So we have a velocity here, which is 6.47, which is ever slightly larger than what the real velocity is. And so that means we know at this point this is the correct answer. But for sake of completeness, let's say you didn't have a multiple choice question and you need to calculate the exact answer. So what you do is you start with this equation right here, and we use a quadratic formula. So we know that t equals minus 10.2 squared, and we already know from here that the plus or minus, that the minus is not going to be valid. So just going to write the plus down because we already know that. And we also can know that here just from this point, that if you have a minus and then you're going to be subtracting another thing, you're going to get a minus number. So subtracting a minus is going to be a minus. So negative times is not possible. So let's just work this out a little bit more. 10, oh, sorry, there's no square root there, because that was done later. 10 10.2 squared. And here we got minus 4 times a minus 104, which becomes plus 408. And because the equation up here, if we had referred to it, we would have been more careful here, is minus b plus or minus b squared minus 4ac divided by 2a. And what we had here, just to remind ourselves, is a equals 1, b equals 10.2, and c equals 102. So, and then all this is divided by 2. Plugging this into the equation, what would we get? So we get 10.2 squared plus 408 equals, and then square root that, and then we go minus 10.2 equals, that's the top part, and then divide that by 2, and yeah, you see this? The time here, the real time, is ever so slightly larger than the estimated time. And so what the real velocity is, the real horizontal velocity is 40 divided by 6.21. Sorry. Oh, gosh. 6.21. And that equals I did a typo here. 40 divided by 6.21. Okay. So that equals 6.44 meters per second. And that is exactly the answer that was provided to us. So the exact answer is, as by calculation, 6.44. The takeaways from this are, always draw a diagram first. The diagram you're drawing is the most important thing you do, because this helps you understand all the parts of the equation. So first, the diagram is most important. The second thing is, once you write the basic equations like we did here, let's do this in a different color. So once we write out the basic equations as we did here, it's kind of important to see, is there anything I can do to kind of eliminate basic cases? And by using just initial velocities, we were able to eliminate all these basic cases. So if we really rush for time, that takes it down to a 50% chance, which makes it a much better possibility. And another thing to bear in mind is, next thing we took advantage of was the fact that we know that the amount of difference between these answers, because the amount of difference, it's not so much the significant digits, it's the difference between the answers. If the difference between the answers is large, then I don't need to do as precise calculation to get the right answer. In other words, I was quite able to use this estimate here, which is basically using nice round numbers to do this. Now, the other thing I want to show you before we end this question is, let's say you did not remember the quadratic equation. So we do know that the equation, well, it doesn't matter, we can use this color. The equation is t squared plus 10t minus 100. And we know that it's going to equal the roots, which is doing the same thing we did before. T minus some number and then plus some number. So this is going to be 100, let's say 100 divided by 7. So let's see, this was 7 here. So what would the other one be? It would be 100 divided by 7. So that's my first guess, 14.2. Now, I'm going to multiply this through, but I think it should be pretty obvious too. Multiplying this through is t squared, because it's this term times that term, and then this term times that term. So t squared, and we have plus 14.2 t, and we got minus 7 t, and these two multiplied together, because we already did that, we know what the answer is, minus 100. So we know that 14 minus 7 is not 10, so it doesn't give 10. So we have to use a different guess. I'm going to use a different color, because that color is not my favorite color. I would actually choose 6. If we choose 6, it would be let's try that. So we try 6, what would we get? And then we can do this if in the case we forgot the quadratic equation. It's just an alternate way, which is kind of useful in case we forgot something. So 100 divided by 6. It's actually not the preferred way, because quite often you got to do more guessing. The quadratic equation with the simplified numbers is the preferred way of doing it, to do it as quickly as possible. But okay, so 16.6. Now, knowing what we did before, we don't need to do all the multiplication. What we do in the difference is going to be 16.6 minus 6, which equals 10.6. It's not the same as the one up here, but it's close. So 6 is going to give us a decent estimate. In fact, we know that it's going to be a little bit, let's see, a little bit larger, because this is too, like, when 7 was, it was too big, and 6 is too small. So it's a little bit larger than 6. So we could try 6.1 and stuff like that, but we know it's close. So if we're just doing this raw, like if we had forgotten the quadratic equation and we just want to get a really simple estimate, 40 divided by 6, what does that equal? 40 divided by 6 equals 6.67. This, I mean, if you just did this, you forgot the quadratic equation and you simply just did the roots. In two guesses, with two reasonable guesses, you would guess 6, and 6 will give you the right answer, because you would know that, okay, you guessed 6.66, and you know right here that this, the t here you guessed is too small, and if the t is too small, the velocity will be too large. So you know the velocity will be larger than the real velocity by a little bit, and you don't know how much in this case, but it's going to be a little bit. And there you go, you get the right answer. So I hope you enjoyed this, and I look forward to the next question. Thank you very much. Bye.